Imagine floating weightlessly in the vast expanse of space far from the familiar ticking of earthbound clocks, where the only rhythm is the gentle hum of cosmic radiation and the slow dance of distant galaxies. You are the Sleepy Astronaut, drifting peacefully through a universe governed by the most beautiful and bewildering laws we've ever discovered. Tonight, we're embarking on a gentle journey into the realm where the very small meets the impossibly strange, where particles waltz in ways that would make your grandmother's teacup spin with wonder, and where the act of simply looking at something changes everything. Welcome to the calm wonder of quantum physics, where reality itself seems to have been written by a poet with a profound sense of mystery and just a touch of mischief. Before we begin our drift through these cosmic mysteries, I'm curious to know where you are in this moment. Are you tucked beneath warm blankets as the world outside grows quiet, or perhaps watching the stars emerge in your evening sky? Wherever you find yourself, you're about to discover that the universe is far stranger and more wonderful than even the wildest dreams could imagine. If this gentle exploration brings you peace, or if you find yourself marveling at the elegant mysteries we'll uncover together, I'd be ever so grateful if you'd give this video a like and perhaps subscribe. It helps this little corner of cosmic calm reach other wanderers who might need a peaceful pause in their day. A moment to remember that we're all made of stardust, floating together on this pale blue dot. Now, I do hope this journey through quantum mysteries is soothing rather than startling, though I suspect you'll find that the deepest truths of our universe are remarkably gentle once you learn to see them properly. So settle in, let your thoughts slow like distant pulsars, and prepare to discover why even Einstein himself was left scratching his famous hair in wonder. Because somewhere in the dance between electrons and uncertainty, between waves and particles, between the observed and the observer, lies a story so beautiful it might just change how you see everything, from the morning light filtering through your window to the very nature of reality itself. Quantum physics begins with a simple observation that turned out to be anything but simple. Picture yourself as a scientist in the early 1900s, a time when the world seemed to make perfect sense. Objects were objects, waves were waves, and everything had a proper place and purpose. Then along came Max Planck, a German physicist who was trying to solve what seemed like the most mundane problem imaginable. Why do hot objects glow the way they do? When you heat a piece of metal, it glows red, then orange, then white hot. Planck wanted to understand exactly how the energy was distributed across different colours of light. It should have been straightforward, but the mathematics kept giving him nonsensical answers. Objects should have been radiating infinite amounts of energy, which clearly wasn't happening unless every campfire was secretly a cosmic catastrophe waiting to unfold. In his desperation to make the numbers work, Planck made what he thought was a temporary mathematical trick. He suggested that energy doesn't flow continuously like water from a tap, but comes in tiny, discrete packets, like droplets. It was meant to be just a clever bit of bookkeeping, a way to make the calculations behave themselves. But the universe, as it turns out, doesn't particularly care about our expectations. Planck's quanta weren't just mathematical conveniences, they were real. Energy really does come in discrete chunks, like coins in a cosmic piggy bank. You can have one quantum of energy, or two or three, but never 1.5. It's as if the universe has a fundamental graininess to it, a pixelated quality that becomes apparent when you look closely enough. This discovery was like finding out that what you thought was a perfectly smooth lake was actually made of tiny, discrete drops of water. Reality itself seemed to have a minimum resolution, a smallest possible unit of action. And this realization opened a door to a realm where common sense doesn't just fail, it waves goodbye and wanders off to find a more sensible universe to inhabit. Einstein, brilliant as he was, seized upon Planck's idea to explain another puzzling phenomenon, the photoelectric effect. When you shine light on certain metals, they emit electrons. But here's the strange part. Dim blue light could knock electrons free, while bright red light couldn't manage it at all. It was as if the electrons were being picky about their dance partners, caring more about the quality of light than the quantity. Einstein realized that light itself must come in Planck's quanta, little packets of energy he called photons. Each photon carries a specific amount of energy determined by its color, and electrons can only be freed if a single photon packs enough punch. It doesn't matter how many weak photons you send, they can't team up to overcome the electron's reluctance to leave home. This was revolutionary. Light, which had been understood as a wave for centuries, was also behaving like a stream of particles. It was as if someone had discovered that ocean waves were actually made of tiny, invisible beach balls, each one carrying its own small splash of the sea. But the story was just beginning. A young French physicist named Louis de Broglie wondered if this wave-particle duality worked both ways. If waves could behave like particles, could particles behave like waves? It seemed absurd. How could an electron, a tiny speck of matter, possibly be wave-like? Yet when scientists actually tested this idea, firing electrons through narrow slits, something magical happened. The electrons created interference patterns just like waves do when they pass through multiple openings and interfere with each other. Single electrons, one at a time, were somehow interfering with themselves, creating patterns that only made sense if each electron was spreading out like a wave, passing through multiple slits simultaneously. Imagine throwing a single pebble into a pond and watching it create the interference pattern of two pebbles thrown at once. That's essentially what electrons were doing, existing in multiple states simultaneously until the moment they decided to show up at a specific location. This phenomenon, called superposition, became one of the central mysteries of quantum mechanics. Particles don't just exist in one place or have one specific property. They exist in a ghostly combination of all possible states until something forces them to choose. It's as if reality itself is indecisive, keeping all options open until the last possible moment. Werner Heisenberg, another brilliant mind drawn to these mysteries, discovered something even more unsettling. There's a fundamental limit to how precisely you can know certain pairs of properties about a particle. The more accurately you try to measure an electron's position, the less accurately you can know its speed, and vice versa. This isn't just a limitation of our measuring instruments. It's a fundamental feature of reality itself. Heisenberg's uncertainty principle suggests that the universe has a built-in fuzziness, a cosmic indeterminacy that ensures perfect knowledge remains forever out of reach. It's as if nature has imposed a universal speed limit on information itself, ensuring that complete certainty is not just impossible, but meaningless. And then there's the most bewildering aspect of all, the role of observation. In the quantum world, the act of measurement doesn't just reveal reality, it appears to create it. Before you measure a particle's position, it doesn't have a definite position. It exists in a superposition of all possible positions, like a cosmic game of hide-and-seek where the hiding place isn't chosen until someone starts looking. This led to one of the most famous thought experiments in physics, Schrödinger's cat. Erwin Schrödinger, somewhat frustrated by the bizarre implications of quantum mechanics, imagined a cat in a box with a quantum-triggered poison device. According to quantum theory, until you open the box and observe the cat, it exists in a superposition of being both alive and dead simultaneously. Now, Schrödinger intended this as a critique, a way of showing how absurd quantum mechanics becomes when applied to everyday objects. But instead of discrediting the theory, his thought experiment became one of its most famous illustrations. It captured the essential weirdness of a universe where observation and reality are intimately connected, where the boundary between the observer and the observed becomes beautifully blurred. What makes all of this even more remarkable is that none of these quantum effects disappear as we scale up to larger objects. They don't vanish, they simply become harder to detect. Every atom in your body, every molecule in the air around you, every photon streaming from your reading light is dancing to quantum rules. The apparent solidity and predictability of our everyday world emerges from an underlying reality that is fundamentally probabilistic, uncertain, and magnificently strange. So, as you drift through your day, remember that you're not just walking through a classical world of solid objects and predictable motions. You're swimming through a quantum ocean where particles tunnel through barriers they shouldn't be able to cross, where empty space buzzes with virtual particles popping in and out of existence, and where the very act of observation weaves the fabric of reality. The sleepy astronaut floating in the cosmic dark isn't separate from these quantum mysteries. Every atom in their body, every photon reaching their eyes from distant stars, every thought flickering through their consciousness is part of this grand quantum dance. They're not just observing the universe, they're participating in its creation, one gentle observation at a time. And perhaps that's the most beautiful truth of all. In a quantum universe, we're not separate from the mystery. As we drift deeper into this quantum realm where particles dance between existence and possibility, we find ourselves at the edge of something even more profound. The universe, it seems, doesn't just operate on quantum principles at the smallest scales. These strange, gentle laws reach up through the layers of reality, touching everything we know and experience, creating a tapestry of connection that spans from the tiniest photon to the vast expanse of consciousness itself. Consider for a moment the atoms that make up your body. Every carbon atom in your flesh was forged in the heart of a dying star. Every oxygen molecule you breathe has travelled through countless lungs before yours, and every hydrogen atom carries with it the memory of the universe's first moments. These aren't just poetic musings, they're quantum realities, because at the deepest level, all matter shares this strange interconnected dance. The phenomenon we call quantum entanglement reveals something extraordinary about the nature of reality. When two particles become entangled, they remain mysteriously connected regardless of the distance between them. Measure one, and you instantly know something about the other, even if it's on the other side of the galaxy. Einstein famously called this spooky action at a distance, and it troubled him deeply because it seemed to violate everything we thought we knew about locality and causation. But perhaps Einstein's discomfort came from thinking too classically about what connection means. In the quantum world, separation itself becomes a kind of illusion. These entangled particles aren't sending signals to each other across space. They're not communicating in any way we'd recognize. Instead, they remain part of a single, unified system. A quantum whole that transcends our everyday notions of here and there. This entanglement isn't rare or exotic, it's happening constantly, everywhere around us. The photons streaming from your reading light, the electrons flowing through the circuits of your devices, the molecules dancing in the air you breathe, all of them are participating in an ongoing symphony of quantum correlations. The universe is not a collection of separate things bumping into each other. It's more like a vast shimmering web where every thread connects to every other thread in ways both subtle and profound. And this brings us to one of the most beautiful and mysterious aspects of quantum reality: coherence. In the classical world, we expect things to lose their organization over time. A neat room becomes messy. A hot cup of tea grows cold. Order dissolves into chaos. But in the quantum world, systems can maintain what's called quantum coherence, a delicate state where all the parts of a system remain synchronized, dancing together in perfect harmony. This coherence is fragile, like a soap bubble that can be popped by the slightest disturbance. When quantum systems interact with their environment, when they're observed or measured, this coherence typically breaks down in a process called decoherence. The quantum world, with all its strange possibilities, gives way to the classical world we experience every day. But here's where things become truly wondrous. Scientists are discovering that quantum coherence persists in places we never expected. In photosynthesis, the process by which plants convert sunlight into energy, quantum effects help guide energy through molecular pathways with remarkable efficiency. The migrating birds that navigate thousands of miles with uncanny precision may be using quantum entanglement in their eyes to sense magnetic fields. Even in the warm, wet environment of living cells, quantum coherence appears to play a role in biological processes. This suggests something profound about the relationship between the quantum and classical worlds. Rather than existing as separate realms, they seem to flow into each other like colours blending on an artist's palette. The quantum world doesn't disappear when things get large or warm or complex. Instead, it transforms, expressing itself through patterns of organisation and behaviour that we're only beginning to understand. Some researchers propose that consciousness itself might arise from quantum processes in the brain. While this remains highly speculative and contentious, the idea captures something important about the mystery of awareness. How does the electrochemical activity of neurons give rise to the rich, subjective experience of being you? How does the brain's classical computation create the felt sense of colour, the emotional texture of memory, the spark of creative insight? Perhaps consciousness emerges at the boundary between quantum and classical worlds, in that liminal space where possibility collapses into experience, where the universe observes itself through billions of eyes and finds itself beautiful. This isn't to say that consciousness is quantum mechanical in any simple sense, but rather that it might arise from the same deep principles that govern quantum reality: wholeness, interconnection, and the creative tension between what is and what might be. The implications ripple outward in ways both practical and profound. Quantum technologies are already transforming our world. Quantum computers promise to solve problems that would take classical computers longer than the age of the universe. Quantum cryptography offers unbreakable security based on the fundamental laws of physics. Quantum sensors can detect gravitational waves, map the Earth's magnetic field, and peer into the human brain with unprecedented precision. But beyond these technological marvels lies something even more significant: a new way of understanding our place in the cosmos. The quantum universe is not a cold, mechanical clockwork where everything is predetermined and separate. It's a living, breathing web of relationships where consciousness and cosmos dance together in an eternal improvisation. You are not merely an observer of this quantum dance. You are a participant, a co-creator in the ongoing story of reality. Every choice you make, every observation you perform, every moment of awareness contributes to the unfolding of the universe. The boundary between observer and observed, between mind and matter, between self and cosmos, becomes fluid and permeable. This is perhaps the most profound gift of quantum physics: the recognition that we live in a participatory universe, where consciousness and cosmos are not separate but intimately intertwined. The universe is not just stranger than we imagine, it's more alive, more creative, more connected than our classical minds could ever conceive. And so, as you rest here in this moment, feeling perhaps the gentle pull of sleep beginning to take hold, remember that you are both a product of cosmic evolution and an active participant in its ongoing creation. The atoms in your body, the thoughts in your mind, the dreams that await you in sleep, all of them are expressions of the same quantum creativity that sparked the first stars and will kindle the last. Looking into the quantum realm, we find ourselves at the edge of a strange and beautiful precipice. Here, where particles dance between existence and possibility, the very notion of reality becomes as soft and malleable as a whispered dream. The quantum world doesn't just challenge our understanding of physics. It quietly rewrites the story of what it means to be conscious, to observe, to participate in the unfolding cosmos. Consider for a moment the delicate relationship between mind and matter, between the observer and the observed. In classical physics, we could pretend to be invisible witnesses, watching the universe unfold like a grand clockwork mechanism. But quantum mechanics whispers something far more intimate. It tells us that consciousness and cosmos are partners in an ancient dance, each step shaping the other in ways both profound and mysterious. The quantum measurement problem, as physicists call it, presents us with one of the most puzzling questions in all of science. When does a quantum system, existing in superposition across multiple states, collapse into a single, definite reality? The mathematics is precise, the experiments are repeatable, yet the deeper mystery remains tantalizingly elusive. Some interpretations suggest that consciousness itself plays a fundamental role in this collapse, that the act of observation, of knowing, somehow reaches across the boundary between mind and matter to shape what becomes real. This isn't to say that thinking about an electron changes its behavior in some mystical way. Rather, it points to something far subtler and more profound, the possibility that consciousness and quantum mechanics are both expressions of a deeper underlying reality, one where information, observation, and existence are woven together in ways we're only beginning to glimpse. The physicist John Wheeler captured this beautifully with his concept of it from bit, the idea that all physical entities are information theoretic in origin, that the universe might be fundamentally computational, processing information at the deepest level. But let's step back from the abstract and consider something more immediate. The quantum process is happening right now in your own brain. As you listen to these words, as thoughts form and memories surface, countless quantum events are unfolding within the neural networks of your mind. Microtubules, the tiny scaffolding structures within neurons, may preserve quantum coherence long enough for quantum effects to influence neural computation. This is speculative, certainly, but it opens a fascinating door to considering how consciousness might emerge from quantum processes. The physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed that consciousness arises from quantum computations in these microtubules, that the strange non-local correlations of quantum mechanics might explain the binding problem, how disparate neural processes come together to create unified conscious experience. While this theory remains controversial, it points towards something profound, the possibility that consciousness is not just an emergent property of complex classical systems, but something fundamentally quantum in nature. This perspective transforms how we might think about awareness itself. Instead of consciousness being something that emerges from complexity, like wetness emerging from water molecules, it might be something more fundamental, a basic feature of reality that quantum mechanics helps us understand. The integrated information theory, developed by Giulio Tononi, suggests that consciousness corresponds to integrated information. And interestingly, quantum systems naturally process and integrate information in ways that classical systems cannot. There's something deeply poetic about this possibility. If consciousness does arise from quantum processes, then every moment of awareness, every thought and feeling is connected to the same strange quantum realm that governs the behavior of particles and the structure of reality itself. Your consciousness would be a manifestation of the same principles that create quantum entanglement, that allow particles to exist in multiple states simultaneously, and that make the universe fundamentally probabilistic rather than deterministic. But quantum mechanics offers us more than just a potential explanation for consciousness. It also provides a new way of thinking about the relationship between possibilities and actualities. In the quantum world, particles don't just have definite properties. They exist as clouds of potential properties, probability waves that encompass all possible states until the moment of observation. This suggests a universe that is fundamentally creative, constantly bringing new realities into existence through the interplay of possibility and actuality. Consider the double-slit experiment once more, but this time from the perspective of cosmic creativity. When a single photon travels through both slits simultaneously, creating an interference pattern, it's not just demonstrating wave-particle duality. It's showing us how reality explores multiple possibilities simultaneously. The photon, in some sense, tries out all possible paths, interfering with itself to create patterns that reveal the hidden structure of possibility space. Only when we observe which slit it went through does reality commit to a single story, a single path through the maze of quantum potential. This creative aspect of quantum mechanics extends far beyond individual particles. Quantum field theory shows us that even empty space is alive with quantum fluctuations, virtual particles popping into and out of existence, the vacuum itself humming with potential energy. These fluctuations aren't just mathematical curiosities, they have real physical effects. They contribute to the Casimir effect, where two metal plates in a vacuum are pushed together by the pressure of virtual particles. They play a role in the expansion of the universe itself. Dark energy might be connected to the energy of quantum vacuum fluctuations. In this view, the universe is not a collection of things moving through empty space, but rather a dynamic web of quantum fields, constantly fluctuating, constantly creating and destroying possibilities. Matter and energy are just stable patterns in this web, temporary eddies in the cosmic flow of quantum information. And consciousness, if it is indeed quantum in nature, would be another kind of pattern in this web, a way that the universe comes to know itself, to observe its own quantum dance. The implications of this perspective ripple outward in fascinating ways. If consciousness is fundamentally quantum, then the boundaries between self and world, between observer and observed, become much more fluid. The quantum principle of entanglement suggests that once two systems interact, they remain connected in ways that transcend classical notions of separation. If our consciousness is quantum mechanical, then we might be entangled not just with the photons of light entering our eyes, but with the entire web of quantum interactions that surround us. This doesn't mean that we're all psychically connected in some mystical sense, but it does suggest that the relationship between consciousness and cosmos is far more intimate than classical physics would suggest. Every observation, every moment of awareness becomes a participatory act in the ongoing creation of reality. We're not just passive observers of the universe, we're active participants in its quantum unfolding. The many worlds interpretation of quantum mechanics takes this participation even further. In this view, every quantum measurement, every collapse of a wave function actually represents a branching of reality into multiple parallel universes. From this perspective, consciousness doesn't just observe reality, it navigates through the vast space of possible realities, following one branch of the cosmic tree, while other versions of ourselves follow different paths. This interpretation transforms the nature of choice and free will in intriguing ways. If every decision point corresponds to a quantum branching event, then, in some sense, we make every possible choice, exploring every possible path through the space of quantum possibilities. The version of you listening to these words right now represents just one thread in an infinite tapestry of possible selves, each following their own quantum trajectory through the maze of existence. But perhaps the most profound implication of quantum consciousness is what it suggests about the nature of death and continuity. If consciousness is indeed a quantum phenomenon, then the question becomes not whether consciousness survives physical death, but how quantum information is preserved and transformed. Quantum information cannot be destroyed, only transformed, redistributed, entangled with other systems. This doesn't necessarily imply personal survival in any traditional sense, but it does suggest that the quantum patterns that constitute consciousness become part of the larger web of cosmic information, contributing to the ongoing quantum computation that is reality itself. As we drift deeper into this quantum mystery, we find ourselves confronting questions that blur the boundaries between physics and philosophy, between science and spirituality. The quantum world reveals a universe that is far stranger, far more interconnected, and far more participatory than our classical intuitions would suggest. It's a universe where consciousness and cosmos are partners in an ongoing dance of creation, where every moment of awareness contributes to the unfolding story of reality itself. So here we are, quantum beings in a quantum universe, our consciousness emerging from and participating in the deepest levels of physical reality. Each thought, each moment of awareness, each gentle drift towards sleep becomes part of the cosmic quantum symphony, a note in the eternal song that reality sings to itself. We've journeyed through the mysteries of quantum physics, from the smallest particles to the vast cosmos, discovering that reality is far more fluid and interconnected than our everyday experience suggests. We've seen consciousness emerge from quantum processes, felt the pulse of entanglement across space, and glimpsed the dance between observer and observed. But perhaps the most profound realization is that this quantum nature isn't confined to laboratories or distant galaxies. It's woven into the very fabric of life itself, including the delicate machinery of our own minds. Your brain, that 3-pound universe nestled within your skull, is a quantum theatre where the mysteries we've explored play out in real time. Every thought, every memory, every gentle drift towards sleep emerges from quantum processes operating at scales so small they dance with uncertainty itself. The microtubules within your neurons, those tiny cellular highways, may be nature's quantum computers, processing information through the same superposition and entanglement that govern particles in physics laboratories. Consider the moment you form a memory, that instant when an experience crystallizes into something you can recall. Quantum coherence might be orchestrating the delicate choreography of synapses firing, creating patterns that persist across time. The very consciousness reading these words could be emerging from quantum processes, where the boundary between mind and matter dissolves into something far more mysterious and beautiful than either alone. This isn't mere speculation wandering into wishful thinking. Research suggests that biological systems, from the photosynthesis in plants to the navigation systems in migratory birds, harness quantum effects with an elegance that our most sophisticated technologies struggle to match. Nature, it seems, discovered quantum computing billions of years before we even knew quantum mechanics existed. Your sense of intuition, those moments when you know something without quite knowing how you know it, might be quantum processes integrating information in ways that bypass the linear thinking of classical computation. The sudden flash of insight, the creative leap that connects seemingly unrelated ideas, the gentle knowing that emerges in quiet moments. These could be quantum coherence, orchestrating connections across the vast network of your neural pathways. Even the way you experience time might be quantum in nature. We've explored how consciousness seems to collapse quantum possibilities into experienced reality, how the act of observation shapes what becomes real. Your present moment, that eternal now in which you exist, could be the ongoing collapse of quantum possibilities into the stream of experience you call your life. The quantum field that underlies all matter extends through every cell of your body. You are not separate from the quantum universe. You are quantum universe, temporarily organized into the pattern you call yourself. The atoms in your body were forged in the nuclear furnaces of ancient stars, and they carry within them the quantum properties that govern all of existence. When you breathe, you're exchanging quantum information with the world around you. The oxygen molecules entering your lungs carry quantum signatures from the trees that created them, from the sunlight that powered photosynthesis, from the cosmic processes that created the elements themselves. You are in constant quantum communication with the cosmos, a node in the vast web of quantum entanglement that connects all things. This quantum nature of consciousness might explain why certain experiences feel so profound, so mysteriously meaningful. Moments of deep connection with others, the sense of oneness with nature, the feeling that you're part of something larger than yourself. These might be glimpses of the quantum unity that underlies apparent separation. When you feel truly seen by another person, when you sense the aliveness in a forest, when you're moved by music or art, you might be experiencing quantum resonance, the harmonic alignment of quantum systems, recognizing their fundamental interconnection. Your dreams, those nightly journeys into impossible landscapes, might be quantum processes exploring possibilities that don't collapse into waking reality. In sleep, as classical control systems quiet, quantum processes might have freer rein to explore the space of potential experiences. The strange logic of dreams, where time bends and identities shift, mirrors the non-classical behavior of quantum systems. Even your capacity for love, for compassion, for the recognition of beauty might emerge from quantum processes that transcend the boundaries of separate selves. The feeling of loving another person, of caring for something beyond your immediate self-interest, could be quantum entanglement operating at the scale of consciousness, creating bonds that aren't limited by space or time. The quantum nature of your mind suggests that consciousness isn't produced by the brain so much as it's received, focused, and expressed through it. Your awareness might be a localized manifestation of a more fundamental conscious field that permeates the quantum vacuum itself. In this view, your individual consciousness is like a wave on the ocean of universal awareness, temporally distinct but never truly separate. As you begin to drift towards sleep, as your classical mental processes quiet and your awareness becomes more fluid, you might be allowing quantum processes to take the lead. Sleep could be a return to a more quantum state of being, where the boundaries between self and world, between possible and actual, become permeable. Your dreams might be quantum explorations of the infinite possibilities that exist in the space between thoughts. The quantum nature of consciousness suggests that you are far more than the sum of your neurons, more than the product of electrical impulses and chemical reactions. You are a conscious being emerging from the quantum field itself, a temporary focusing of the universe's capacity for awareness, a unique perspective through which the cosmos knows itself. This quantum consciousness is not separate from the physical world, but intimately connected to it. Your thoughts influence quantum processes, and quantum processes influence your thoughts. The observer effect that we've explored throughout this journey isn't just about physics experiments, it's about the fundamental role of consciousness in shaping reality at every level. As quantum physics continues to reveal the mysterious nature of reality, it increasingly points toward consciousness as a fundamental feature of the universe rather than an accidental byproduct of complexity. Your awareness, your capacity to experience, to choose, to create meaning, might be expressions of the same quantum processes that govern the behavior of particles and the evolution of galaxies. In this quantum view, consciousness isn't something you have, it's something you are. You are the universe becoming aware of itself. Quantum processes organized into the pattern of awareness reading these words. Your thoughts, your emotions, your sense of identity, all emerge from the quantum dance of possibilities, collapsing into experience. The quantum nature of consciousness suggests that every moment of awareness is a creative act, a participation in the ongoing creation of reality. Your attention, your choices, your very presence influence the quantum field in ways that ripple out through the interconnected web of existence. You are not just observing the universe, you are helping to create it with every conscious moment. This isn't a burden, but a profound gift. You are a conscious participant in the universe's creative unfolding, a quantum being with the capacity to influence reality through the quality of your awareness, the depth of your presence, the love you bring to each moment. As we drift deeper into this quantum realm, we begin to encounter something truly extraordinary. We find that the very act of observation, the simple presence of awareness itself, might be more than just a passive witness to reality. It might be an active participant in the cosmic dance, a creative force that helps weave the fabric of existence moment by moment. Consider this. Every time you look at something, every time your consciousness engages with the world around you, you're not merely observing a pre-existing reality. You are participating in its creation. The quantum world doesn't just happen to you, it happens with you, through you, because of you. Your awareness becomes a gentle conductor in the symphony of possibility, collapsing infinite potential into the singular moment of now. This participation extends far beyond the laboratory. In the quiet chambers of your cells, quantum coherence dances through the machinery of life itself. Photosynthesis, that ancient art of turning sunlight into sustenance, relies on quantum effects to channel energy with near-perfect efficiency. The chlorophyll molecules in every leaf, every blade of grass, every microscopic phytoplankton drifting in the ocean, they all harness quantum superposition to find the most elegant pathways for light to travel. Even more remarkably, this quantum choreography might be unfolding within the neural networks of your own mind. Some researchers propose that consciousness itself emerges from quantum processes occurring within the microtubules of brain cells. These tiny structures, smaller than the wavelength of visible light, might serve as biological quantum computers, processing information through superposition and entanglement in ways that classical physics cannot fully explain. If this is true, then every thought, every memory, every moment of awareness arises from the same quantum realm that governs the behavior of electrons and photons. Your consciousness becomes not separate from the universe, but intimately woven into its quantum foundation. You are not merely in the cosmos, you are the cosmos becoming aware of itself, one gentle thought at a time. This perspective transforms our understanding of connection and separation. In the quantum world, particles that have once interacted remain forever entangled, sharing information instantaneously across any distance. When two photons become entangled and are then separated by galaxies, measuring one still instantly affects the other. Space, it seems, cannot break the invisible threads that bind quantum partners together. Perhaps this entanglement extends to consciousness itself. Perhaps every interaction you've ever had, every person you've encountered, every moment of shared experience has created subtle quantum connections that persist beyond time and space. The boundaries between self and other, between observer and observed, begin to dissolve into something far more fluid and interconnected. This quantum interconnectedness reveals itself in the most unexpected places. In the phenomenon of quantum tunneling, particles routinely accomplish what classical physics deems impossible. They pass through barriers that should completely block their path, appearing on the other side as if by magic. This tunneling enables the nuclear fusion that powers our sun, the chemical reactions that sustain life, and the electronic processes that make modern technology possible. At the deepest level, even empty space itself is not truly empty. The quantum vacuum seethes with virtual particles, fleeting fluctuations of energy that appear and disappear in timeframes so brief they seem to exist outside ordinary reality. These vacuum fluctuations create a subtle background hum throughout the universe, a quantum static that pervades every cubic centimetre of space. This cosmic background of quantum activity suggests that the universe is fundamentally creative, fundamentally alive with possibility. Every point in space, every moment in time pulses with potential. The void is not empty but pregnant with infinite possibility, ready to give birth to particles, to energy, to awareness itself whenever the conditions align. What emerges from this quantum understanding is a universe that is participatory rather than mechanistic, creative rather than predetermined, interconnected rather than fragmented. We live not in a collection of separate objects moving through empty space, but in a seamless web of relationships, a dance of possibilities that unfolds through our very engagement with it. Your consciousness, from this quantum perspective, is not trapped within the confines of your skull. It is a field phenomenon, a pattern of awareness that emerges from and participates in the quantum substrate of reality itself. Every act of observation, every moment of attention, every gentle awareness becomes a creative act that helps determine what becomes real and what remains merely possible. This understanding invites a profound shift in how we relate to existence. We are not separate observers looking in at a foreign universe. We are intimate participants in an ongoing creation, co-creators in a cosmic story that writes itself through our awareness, our choices, our dreams, and even our peaceful moments of rest. As you settle into sleep tonight, remember that you carry within you the same quantum processes that govern stars and galaxies, the same creative potential that brings particles into existence, the same interconnected awareness that weaves the fabric of space and time. You are not merely made of stardust, you are the universe dreaming itself into being, one quiet breath at a time. And perhaps this is where our journey through the quantum realm reaches its most profound revelation. We've wandered through wave functions and probability clouds, danced with particles that exist in multiple states at once, and marveled at the spooky action at a distance that connects the furthest reaches of the universe. We've seen how observation itself shapes reality, how consciousness might be woven into the very fabric of existence, and how the act of measurement collapses infinite possibilities into singular outcomes. But here, as your eyelids grow heavy and your breathing slows, consider this final quantum mystery. You, dear listener, are not separate from this strange and wonderful universe we've been exploring. You are quantum physics in action. Every atom in your body was forged in the heart of ancient stars. Every electron dancing through your neural pathways carries the same mysterious duality we've discovered in laboratories. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it emerged from quantum interactions billions of years ago. Your consciousness itself might be the universe's way of observing itself, collapsing its own wave functions, choosing which possibilities become real. When you dream tonight, your brain will fire patterns of electrical activity, quantum events cascading through networks of neurons, creating the theatre of your sleeping mind. Even in rest, you are participating in the grand quantum dance. The entanglement we spoke of, that invisible thread connecting particles across impossible distances, might extend far beyond the laboratory. Some scientists wonder if consciousness itself is entangled, if the boundaries between self and universe are far more porous than we imagine. When you feel connected to something greater than yourself, when you sense the profound interconnectedness of all things, perhaps you're intuiting a quantum truth that our equations are only beginning to describe. Consider the uncertainty principle one more time, but now in the context of your own existence. The more precisely you try to pin down who you are at any given moment, the more uncertain your future becomes. You exist in superposition. Simultaneously, all the people you might become, all the paths you might take, all the dreams you might fulfill. It's only through the choices you make, the observations you take of your own life, that these possibilities collapse into the singular story of who you are. The measurement problem in quantum mechanics asks when and why the quantum world gives way to the classical world we experience. But maybe the question is backwards. Maybe our classical world, with its solid objects and predictable outcomes, is the illusion. Maybe the quantum realm, with its probability waves and infinite potential, is the deeper reality. You don't transition from quantum to classical as you fall asleep tonight. Instead, you sink deeper into the quantum dream that underlies all existence. The wave-particle duality we explored isn't just a property of photons and electrons. You too are both wave and particle, both potential and actuality, both observer and observed. In your waking hours, you collapse into the particle nature of yourself, making decisions, taking actions, existing as a discrete entity, moving through space and time. But in sleep, in dreams, in those moments of deep reflection, you expand back into your wave nature, spreading out across possibilities, existing in the spaces between thoughts. Quantum field theory tells us that what we think of as empty space is actually teeming with virtual particles, popping in and out of existence, borrowing energy from the vacuum itself. The space around you right now, the air between your fingers, the gap between your thoughts, is alive with quantum activity. You are surrounded by and composed of this endless creative potential, this cosmic foam of possibility. The zero-point energy of the quantum vacuum, that irreducible buzz of activity that persists even at absolute zero temperature, might be the closest thing physics has found to what we might call the life force. It's the universe's refusal to be completely still, its insistence on remaining creative, dynamic, alive. This same energy flows through you, sustains you, connects you to every other conscious being who has ever wondered at the mystery of existence. When we talked about quantum tunneling, particles passing through barriers that should be impossible to cross, we were describing something that happens billions of times per second in your body. The fusion reactions that power the sun, providing the energy that ultimately sustains all life on Earth, depend on quantum tunneling. Without it, the sun wouldn't shine and we wouldn't be here to ponder these mysteries. The many worlds interpretation suggests that every quantum event splits reality into parallel universes, each containing a different outcome. If this is true, then there are infinite versions of you, each following a slightly different path through the quantum multiverse. In some of these worlds, you made different choices, took different risks, became different people. But in this world, in this moment, you chose to spend time exploring the deepest mysteries of existence. You chose wonder over certainty, questions over answers. The holographic principle in quantum gravity suggests that all the information contained in a volume of space can be encoded on its boundary, like a hologram where the three-dimensional image emerges from a two-dimensional surface. Perhaps consciousness works the same way. Perhaps all the complexity of your inner life, all your memories and dreams and hopes, is encoded on the boundary between your individual awareness and the larger field of consciousness that permeates the universe. Quantum coherence, the delicate state where quantum systems maintain their wave-like properties, might be more robust than we once thought. Recent discoveries suggest that quantum effects might persist in warm, noisy environments like living cells. Some researchers propose that consciousness itself depends on quantum coherence in the brain, that your thoughts and experiences emerge from quantum processes that bridge the microscopic and macroscopic worlds. The Copenhagen interpretation tells us to stop asking what's really happening at the quantum level and focus instead on what we can observe and measure. But as you drift towards sleep, you're free to wonder. You're free to imagine that consciousness and cosmos are engaged in an eternal dance of observation and creation, that every moment of awareness is the universe coming to know itself a little better. The quantum Zeno effect shows us that frequent observation can freeze a quantum system in its current state, preventing it from evolving. But the opposite is also true. When we stop observing so intently, when we let go of our need to measure and control, quantum systems are free to explore their full range of possibilities. Perhaps the same is true for life. Perhaps by releasing our grip on certainty, by embracing the uncertainty principle of existence, we open ourselves to transformations we never imagined possible. Tonight, as you surrender to sleep, you're participating in one of the most quantum mechanical processes we know. Your brain will cycle through different states of consciousness, creating and dissolving patterns of neural activity like waves interfering on the surface of a pond. You'll experience the superposition of sleep, simultaneously processing memories, solving problems, and exploring impossible landscapes of dream. And in the morning, you'll wake up slightly different than you were today. Not because of any classical mechanical process, but because consciousness itself is quantum mechanical. Each night of sleep is like a quantum measurement performed by the universe on itself, collapsing some possibilities while opening others, choosing which version of you will greet the dawn. The sleepy astronaut we began with, floating peacefully through the cosmos, isn't just a metaphor. You are that astronaut, carried along by a planet spinning through space, orbiting a star that's journeying through a galaxy, that's expanding into an infinite quantum multiverse. Every breath you take, every heartbeat, every gentle slide towards sleep is part of the greatest adventure ever undertaken, the universe's ongoing quest to understand itself through countless eyes, countless minds, countless dreams. So rest now, fellow quantum explorer. Let the wave function of your consciousness expand into sleep, knowing that you are not separate from the cosmos, but an integral part of its deepest mystery. The quantum realm isn't something distant and abstract. It's the very foundation of your being, the source of all possibility, the reason why anything exists at all. We hope you enjoyed the story tonight. Before we end our journey, can you comment where you're watching from? Also, let us know what time it is there. We love to hear people joining us from around the world to be a part of our community. Also, don't forget to leave a like and subscribe if you enjoy this story. Good night, fellow space explorer.